Hello children, hope you are all fit and fine. Welcome to the science session. Today we are going to see the lesson measurement from physics of standard 7. Unit 1 measurement. Measurement. Introduction. How are the articles and materials shown in the picture measured? How will you ask the shopkeeper to buy the vegetables and to buy the milk? And when purchasing cloth to stitch your uniform, by simply asking vegetables, milk, or cloth. And when someone asks you how long will you take to reach the school, how will you answer? Simply by saying one or two? No. To say everything, we should denote is quantity. In day-to-day life, we measure many things such as the weight of fruits, vegetables, food grains, volume of liquids, temperature of the body, speed of the vehicles, etc. Here, the vegetables are shown in the pictures are measured in the quantity kilogram. The milk is measured in liter. The cloth measured in meter. The time measured in seconds. Physical quantities. Quantities such as mass, weight, distance, temperature, volume are called physical quantities. A value and a unit are used to express the magnitude of a physical quantity. For example, Suresh walks 2 kilometers every day. In this example, 2 is the value and kilometer is the unit used to express the magnitude of distance, which is a physical quantity. Fundamental and derived quantities. Generally, physical quantities are classified into two types, namely fundamental quantities and derived quantities. Fundamental quantities. A set of physical quantities which cannot be expressed in terms of any other quantities are known as fundamental quantities. Their corresponding units are called fundamental units. There are 7 fundamental physical quantities in SI units. What are they? Length, mass, time, electric current, temperature, amount of substance, luminous intensity. What is the SI unit of length? It's meter and its symbol is M. For mass, it's kilogram. The symbol kg. For time, second. The symbol S. The electric current, ampere. Symbol A. Temperature, Kelvin. Symbol K. Amount of substance, mole. Symbol MOL. Luminous intensity, candela. Symbol CD. Derived quantities. The physical quantities which can be obtained by multiplying, dividing, or by mathematically combining the fundamental quantities are known as derived quantities. Their corresponding units are called derived units. 5 derived quantities are given in the table. First one, area. What is the formula to derive the area? It is length into breadth. So now we are going to derive the unit. So what is the unit of length? The basic unit of length is meter. So to breadth, the same meter. So here to measure the breadth also we are using scale, is it? So we are using meter. So m into m is equals to square meter or meter square. Then volume. What is the formula to derive the volume? It is length into breadth into height. So in the same way, it is also m into m. That is equals to cubic meter or meters cube. Speed is equals to distance per time. So what is the basic unit to denote the distance? It's meter. Yes, the basic quantity to measure the distance is meter. So meter per what for time? It is second. So S. So meter per seconds or meter second inverse. Electric charge is equals to electric current into time. What is the basic unit of electric current? Yes, it is A, ampere. Then for electric current, it's ampere, and for time, it is second. So A into S or coulomb. Then density is equals to mass per volume. Here, what is the fundamental unit of mass? It is kg. And for volume, as we already derived in the table, that is meters cube. So kilogram per meters cube. Now we are going to see the derived quantity area. The area is a measure of how much space is there on a flat surface. So what is the formula to derive the area? Area is equals to length into breadth. The unit of area is meter into meter. So meter square. I'll read as square meter. So area is derived quantity as we obtain or by multiplying twice of the fundamental quantity length. Problem related to finding area. What the area of a 10 square each of side of 1 meter. So what's the formula to find out the square? Yes, it is side into side. So 1 meter into 1 meter is equals to 1 square meter. So area of 10 square is equals to 1 square meter into 10. So 10 square meter. Even though the area is given in square meter, the surface area need not to be square in shape. Area of regularly shaped figures. Now we are going to see the area of some regularly shaped figures. First one, square. What's the formula to find out the area of square? Yes, it is side into side. Note the diagram. A into A is equals to A square. Then rectangle. The formula length into breadth. Note the diagram. L into B is equals to LB. Circle. Pi into radius square. Note the circle. Pi into r square is equals to pi r square. Triangle 1 by 2 into base into height. Note the diagram 1 by 2 into b into h. Now we are going to see some problems related to the area of regularly shaped figures. Find the area of the following regular shaped figure. First one, a rectangle whose length is 12 meter and breadth is 4 meter. What is the formula to find out the area of rectangle? As it is length into breadth. So 12 into 4 is equals to 48 square meter. Simple. Then a circle whose radius is 7 meter. What's the formula to find out the area of circle? Yes, it is pi into r square. What's the pi value? Yes, it is 22 by 7. So 22 by 7 into r square. So 7 into 7. So that is equals to 154 square meter. 7 and 7 is going to cancel out. 22 into 7 is equals to 154 square meter. A triangle whose base is 6 meter and height is 8 meter. So what's the formula to find out the area of triangle? As it is 1 by 2 into base into height. Substitute the value of base and height in the formula. 1 by 2 into 6 into 8. 2 and 6 is going to be cancelled out. So 3 into 8 is equals to 24 square meter. Area of irregularly shaped figures. In our daily life, we encounter many irregularly shaped figures like leaves, maps, flowers, peacock feathers, stickers of stars, etc. The area of such irregularly shaped figures cannot be calculated using any formula. How can we find the area of these irregularly shaped objects? We can find the area of these objects with the help of a graph sheet. The graphical method can be used to find the area of irregularly shaped figures. This method can be used to find the area of regularly shaped figures also. In the case of square and rectangle, this method gives the area accurately. Now we are going to see the next derived quantity, volume. The amount of space occupied by a three-dimensional object is known as its volume. So what's the formula to find out the volume? It is surface area into height. Here, length into breadth covers the surface area. So surface area into height. That means length into breadth into height. So the SI unit of volume is cubic meter. That means meter square. Now we are going to see the volume of some regularly shaped objects. First one, the rectangular prism. That means cuboid. This is in the cuboid shape. So what's the formula to find out the volume of cuboid? It is length into breadth into height. So L into B into H. Then cylinder. What's the formula to find out the volume? Yes, it is pi into radius square into height. So pi r square h. Next, cube. What's the formula to find out the cube? Yes, it is side into side into side. So a is cube. Then sphere. What's the formula to find out the volume of sphere? Yes, it is 4 by 3 into pi into radius cube. That means 4 by 3 pi r cube. Volume of liquids. Liquids also occupy some space and hence they also have volume. But liquids do not possess any definite shape, isn't it? So, the volume of a liquid cannot be determined as in the case of solids. When a liquid is poured into a container, it takes the shape and volume of the container. The volume of any liquid is equal to the space that it fills and it can be measured using a measuring cylinder or measuring beaker. The measuring cylinder and the measuring beaker are given in the picture. The volume of a liquid is equal to the volume of space it fills in the container. This can be directly observed from the readings marked in the measuring container. If we notice the measuring cups given in the figure carefully, we can observe that the readings are marked in the unit of ml. This actually represents milliliter. To understand this unit of volume, let us first understand how much a liter means. Liter is the commonly used unit to measure the volume of liquids. We can understand that the volume is cubic centimeter if the dimensions of the objects are given in centimeter. This cubic centimeter is commonly known as cc. A volume of 1000 cc is termed as 1 liter. So 1 liter is equals to 1000 cc or centimeters cube. So 1000 ml is equals to 1 liter. 1 liter is equals to 1000 ml. Volume of irregularly shaped object. As we discussed earlier, that there are no formula to determine the volume of irregularly shaped object. But the volume can be determined using a measuring cylinder and water. Look at the picture. Note the volume of water from the readings of the measuring beaker. What it is? It is 10. Take it as V1. Now, put a stone into the beaker. This has to be done such that the stone does not touch the walls of the measuring cylinder. Now, the level of the water has raised. Note the volume of water. It is 30. And take it as V2. The volume of the stone is equal to the raise in the volume of water. So, what's the formula? It is V2 minus V1. So, 30 minus 10 is equals to 20. So, the volume of stone is 20. Now, the next derived quantity, density. Take water in a beaker and drop an iron ball and a cork into the water. What do you observe? The iron ball sinks and the cork floats as shown in the picture. Can you explain why? If your answer is heavy object sinks in water and lighter objects floats in water, then why does a metal coin sinks in water whereas a much heavier wooden log floats? These questions can be answered when we understand the concept of density. To understand the concept of density, let's do one activity. Take an iron block and a wooden block of same size, say of kilogram or 1 kilogram. Measure their volume. Which one of them has more volume and occupies more volume? Wooden block occupies more volume than the iron ball of same mass. Also, we observe that the wooden block is lighter than the iron block of same size. Take an iron ball and a wooden block of the same size. Weigh them and measure their mass. Which one of them has more mass? Yes, the iron ball will have more mass than the wooden block of the same size. What's the reason? The lightness or heaviness of a body is due to its density. If more mass is packed into the same volume, it has greater density. So the iron ball will have more mass than the wooden block of the same size. Definition of density. Density of a substance is defined as the mass of the substance contained in unit volume. If the mass of a substance is m, volume is v, density is equals to mass per volume. In short form, D is equals to m by v. Unit of density is kilogram per meters cube. For mass, we are using the unit kilogram, and for volume, we are using the unit meters cube. The CGS unit of density is gram per centimeters cube. Density of different materials. Different materials have different densities. The materials with higher density are called denser, and the materials with lower density are called rarer. The density of some widely used materials at room temperature is listed in the table. First one, the material air. What is its nature? It's a gas. What's its density? It's 1.2 kilogram per meters cube. In the same way, kerosene 800 kilogram per meters cube. For water, 1000 kilogram per meters cube. It is in the liquid form. Next, mercury 13,600. Wood 770. Aluminium 2700. Iron 7800. What is it form? It's a solid. Copper 8,900. For silver 10,500. For gold 19,300 kilogram per meters cube. Relationship between density, mass and volume. The relationship between mass, density and volume are represented in the density triangle. From the density triangle, we can derive the formulas very easily. So, if I need density, what's the formula? It is m divided v. So, mass per volume. If I need mass, what's the formula? D into v. So, density into volume. If I need volume, what's the formula? M divided by D. So, mass per density. Problems related to density. A solid cylinder of mass 280 kg has a volume of 4 meters cube. Find the density of cylinder. What's the formula to find out the density? Yes, it is mass per volume. So density of cylinder is equals to mass of cylinder by volume of cylinder. So 280 by 4, that is equals to 70. What is the unit of volume? Yes, it is kilogram per meters cube. Next, a box is made up of iron and it has a volume of 125 centimeters cube. Find its mass. Here, the density of iron is 7.8 gram per centimeters cube. What's the solution? The same. What's the formula for the density? It is mass per volume. So we need mass. So take out the mass. Now the formula will be volume into density. So 125 into 7.8 is equals to 975 gram. Why we are using gram here? Because the density of iron here it is denoted as gram. Next, a sphere is made from copper whose mass is 3000 kilogram. If the density of copper is 8900 kilogram per meters cube, find the volume of the sphere. Density is equals to mass per volume. We need the volume, so take out the volume. Now the formula will be mass per density. So simply substitute the values 3000 by 8900. Cancel out these two zeros. Now we will get 30 by 89. It will give the answer 0.34 meters cube. Measuring distance of celestial bodies. Normally, we use centimeter, meter and kilometer to express the distance that we measure in our daily life. But for space research, astronomers need to measure very long distance, such as the distance between the Earth and a star or the distance between two stars. To express this distance, the following units are used. What are they? They are astronomical unit and light year. Astronomical unit. We all know that the earth revolves around the sun in an elliptical orbit. Hence, the distance between the sun and the earth varies every day. When the earth is in its perihelion position, perihelion is position of the shortest distance between the earth and the sun. The distance between the earth and the sun is about 147.1 million kilometer. When the earth is in its farthest position, that is, the distance between the earth and the sun is the largest. It's called aphelion position. The distance is 152.1 million kilometer. So, the average distance between the earth and the sun is about 149.6 million kilometer. This average distance is taken as one astronomical unit. One astronomical unit is defined as the average distance between the earth and the sun. So, one astronomical unit is equals to 149.6 million kilometer or 149.6 into 10 to the power of 6 kilometer or 1.496 into 10 to the power of 11 meter. Light year. The nearest star to our solar system is Proxima Centauri. It is at a distance of 2,68,770 AU. We can clearly see that using the astronomical unit for measuring distance of stars would be difficult. Therefore, astronomers use a special unit called light year for measuring the distance in deep space. One light year is defined as the distance traveled by light in vacuum during the period of 1 year. So 1 light year is equals to 9.46 into 10 to the power of 15 meter or 94,607 into 10 to the power of 12 kilometer. It's nearly 6 trillion miles. So how we can derive it? By the formula speed of light into distance traveled by light in 1 year. The speed of light is equals to 3 into 10 to the power of 8 or 300 into 10 to the power of 5. The distance traveled by light in 1 year is equals to 3.153 into 10 to the power of 7 or 3154 into 10 to the power of 7 seconds. So by substituting these 2 value, we will get the answer 9.46 into 10 to the power of 15 meter, or 946 into 10 to the power of 12 meter, or 95 trillion kilometer. In this lesson measurement, we have learned the physical quantity and its classifications, fundamental quantities and derived quantities and their units. In derived quantities, we have learned area, volume and density. In area, we have learned area of regular objects, area of irregular objects. In volume, we have learned volume of regular objects, volume of liquids and volume of irregular objects. In density, we have learned definition of density and its units, theory of interatomic distance, density of different materials, relation between density, volume and mass. In fundamental quantities, we have learned the measurement of very long distance, the astronomical unit and light year.